Hello everyone, welcome to Vinoth tutorials. In this video, we are going to learn about how to find the inverse of a matrix using elementary row operation. It is always very curious where exactly these concepts are used. When you consider data encryption, 3D games modeling, these are all the places where we use inverse of matrix. Now we will solve a sample problem. Let's consider a matrix A, which is 3 cross 3 matrix. Now we have to find the A inverse, that is inverse of a matrix. Before directly applying this row elementary operation, we have to check whether the determinant of this value is not equal to 0. That is, if this matrix is a non-singular matrix, then only A inverses exist. So how we will find the determinant? So determinant of A is equal to 1 of 4, 3, 3, 4, 3 of 1, 3, 1, 4, 3 of 1, 4, 1, 3. So in case if you are new, just watch the previous videos. I have already explained how to find the determinant of a matrix, which is equal to 1 of 16 minus 9, that is principal diagonal minus offset diagonal. Like that you have to apply for every value or minus 3. So the final answer is 1. Therefore determinant equal to 1. This means it is non-singular matrix, which implies A inverse exists. So this is the first prerequisite step while solving the inverse of a matrix. After this, we already know a property. Whenever you multiply to any matrix with an identity matrix, we will get the same matrix, that is A. The same equation can also be written as A equal to I not A. So what we are going to do here is we are going to change this particular matrix to an identity matrix. While converting this matrix to an identity matrix, this identity matrix will change to a inverse matrix. The value what we are getting it in this particular position is our A inverse. We'll see how to do that. So now applying row elementary operation. Then for this particular equation, first we will make it as a matrix. What is the value of matrix A? 1. So the matrix of A equal to, and what is the value of identity matrix? It's a 3 cross 3 dot A. Now what is our aim? We have to form an identity matrix. So it is already 1, so no need to change. Then we have to convert this value to 0. In the previous video we have discussed we have a 3 properties. Using that we have to convert this 1 to 0. R2 implies R2 minus R1. When you do subtract between these two values, then the value will be equal to 0. This particular rule you have to apply for second row of this matrix and the identity matrix. That thing you have to remember. The first row 1, 3, 3. Then what is the row 2 minus row 1? 1 minus 1, 4 minus 3, 3 minus 3. So the value will be 1 minus 1, 0, 4 minus 3, 1, 3 minus 3, 0. The remaining row you can write as it is. Equal to. Even for the identity matrix, we have to apply this rule. So 0 minus 1, minus 1, 1 minus 0, 1, 0, then 0, 0, 1. Always remember you have to put A. Using the first rule, we derived this particular matrix. The next step is we have to convert this particular 1 value to 0. So what will be the best idea? we can do this with first row. That is R3 implies R3 minus R1. The first row remains the same, second row remains the same. Then when we apply this particular R3 minus R1, which is nothing but 1 minus 1, 3 minus 3, 4 minus 3. So the value will be 1 minus 1 0, 3 minus 3 0, 4 minus 3 1, which is equal to same rule. So the first row remains the same, second row remains the same. Now 0 minus 1, 0 minus 0, 1 minus 1. What is the value? 0 minus 1 minus 1, 0, then 1. I hope you are clear till this. Using this rule we got this matrix. Now, so this particular we have changed to 0 and it is already 1 in the diagonal axis. The next is we have to convert either this or this value to 0. Let's consider this 3. Now, what rule if you apply, this 3 will change to 0. The rule is row 1 will change to row 1, and in order to change this 3 to 0, the row 3 needs to be multiplied by 3. When things go complicated, it is always a best practice write like this. So the row 1 is 1 3 3 and minus 3 row 3, which is equal to 0 0, then minus 3. When you do a subtraction, we already know 1 minus 0, 1, 3 minus 0, 3, and this will change to 0. So this is the expected value. Same rule for R1, it is 1 0 0, then minus 3 R3. So minus into minus 1, it is plus 3, 0, then minus 3. When you subtract this, 4 0 minus 3. So what will be the final matrix? We are applying it on the row 1. So the row 1 value is 1 3 0. The row 2 value remains the same, that is 0 1 0. The row 3 value 0 0 1, equal to 4 0 minus 3, then minus 1 1 0 minus 1 0 1 dot a. These values. Now the last cell, this particular 3 needs to be changed to 0. What rule you will apply? Can you guess? It is just a common sense. R1 with R2 will give this particular 3 value as 1 without affecting these two values. What I mean to say is R1 implies R1 minus with this value 3 R2. If you apply this rule, we know what is an R1 value. R1 value is 1 3 0. Then minus 3 R2 value, just multiply with minus 3 0 minus 3 then 0. What will be the answer? If you add 1, this will change to 0, this will change to 0. For identity, R1 we know 4 0 minus 3, then minus 3 R2. So minus 3 into minus 3 plus 3, then minus 3, then 0. If you add, it is 7 minus 3 minus 3. Using this value, we will try to form the matrix. So the first row is 1 0, 0. Second row 0, 1, 0. Third row 0, 0, 1. So we formed identity matrix, and this value is first row 7 minus 3 minus 3, then second row minus 1 1 0, then minus 1 0 1 dot A. At the time this particular A matrix changes to identity matrix, this particular value we call it as A inverse. Therefore A inverse equal to, that's it. This is how we have to calculate the A inverse. Hope you got an idea about A inverse, but my suggestion is try to solve the same problem. If you able to derive this particular result, then you are clear on it. That's the end of this video. Thanks for watching. Happy learning.